Hi guys, feel free to interrupt me if you want to stop for quick questions anytime you feel like. So I just learned about this sanctuary technology the other day, so I thought I'd put it up there for people to understand it. But I've been working in related technologies for maybe 15 or 20 years and have quite a bit of background in that, mostly from a human rights perspective, working in authoritarian countries. So the idea is tech tree in the regular world is super complicated. Your iPhone involves conflict minerals from Africa. You've got to have all these single source suppliers to get anything done, international trade agreements, etc. And as an individual in a world that's kind of closing around you in that sense, what can you do to kind of build your own less dependent, more private, independent network so you can express your freedom and values? So one initiative, which started, I think, 25 years ago at this point, is open source ecology, which is kind of an extreme version of this, which is a question, could you build civilization independently? So this is 50 machines that can all build each other, that could in theory start in a shipping container with a computer and a little local AI that helps you build them all. And when it was originally made, there was no little local AI to help you, so it had to be documented with copious videos and instructions. This project has been around for a while now and has put a lot of labor into building some of those machines. There's a 3D printer that can mostly 3D print itself, iron workers, tractors, bread ovens, and it's gone all the way up to building modular houses. So it takes kind of a software approach to the physical world, right? So you've got open source software built with a swarm of people in a couple of weeks. And their designs are shared online and are evolvable and localizable and things like that. So that's called the Open Building Institute. And these systems are all designed to be self-contained, right? To be off-grid, to not have as few external dependencies as possible, and to be built with materials that come out of the construction set of those other machines, including generating its own solar panels and plastic, right, from recycled bottles. All the materials in the house are generated by the system. Is the end goal. And you know, they're partway there right now, including all the designs for the stove, the electronics, everything else. So this has gone through lots of phases. This is a video where you can see their tractor having gone through, like, I think now it's been through 8 or 9 iterations, but it's made with like Tinker Toy-like parts. So you can bolt it together, take it back apart, and reuse the pieces in subsequent versions in some cases. And there's a power cube on the back that's with hydraulic quick connect couplers, so you can take the engine off of one machine and pop it on the other really quick. So this is kind of software composability in the hardware space for rapid prototyping. This is an example of one of the enabling tools. This allows you to make bricks out of the dirt under your property. So when you're digging your foundation, you pour them in here, you make the bricks that compose the walls, so you don't have to buy them. So anyway, this nonprofit has been going for a long time. It built its own workshops and facilities, but the open hardware world is really tough compared to open software. It costs money, it takes time and skills, but increasingly, as the ecology advances, there are more and more machines that are like laser cutters and steel mills, things that are work in an automated fashion and don't require those skills. So this has gone all the way into the real world, and now there have been a number of different properties and houses built using the technology. Some janky, some very successful. And you know, so looking to the future for projects like this, they've now started building, you know, greenhouses. We have a geothermal greenhouse that can produce warm climate crops in 4 seasons. So it takes you know, the ground underneath our feet is pretty much static temperature year-round. Around here, it's probably like 55 degrees or something if you just go down a few feet. So you can run pipes through the ground and pull that air to cool in the summer and heat in the winter, and produce a local greenhouse that grows food. And going beyond that, you know, into biotech projects. So we started looking at ecosystems preservation and agriculture, and doing experiments with plant traits using AI. So here's an example of a local AI rig. There's a little tiny box there by Oxford Nanopore, and that actually does genetic and epigenetic sequencing of samples, and you can see a little stack of flow cells there. So you don't have to send it to a lab. You can literally take the plant tissue or animal tissue right from whatever you're trying to sequence, pop it in your own lab, pull it onto your own local AI computer. It will run nearly in real time on an RTX 6000, maybe even in real time, and you can have a sequence within hours or days. Okay, so going to the extreme other side, we were looking at, how can people communicate, right? Because when you get to that level, it's very difficult to communicate on your own infrastructure. Mesh networks don't go very far. And we kept getting asked to communicate with people in authoritarian countries under difficult circumstances at the Human Rights Foundation. So I was trying to come up with a solution for that. What you see above is a map that gets updated every 3 minutes with the real-time internet latency all around the world. And you can see these little, well, actually you can't up there, but there's little red lines that show where the Russian cable cuts were and how the internet routed around the damage. And this allows us to simulate the undersea cables getting cut. And in the map, the colors are the authoritarian status of the state. So this is like a live map that has all the data centers, including all the frontier AI data centers, to kind of simulate geopolitical situations. So right here we have the Strait of Hormuz being cut, and you can see the little red dots indicate all the places that go offline when you do that. So we have built or donated to a bunch of little offline toolkits. I'm just going to pop through a couple real quick here. Butterbox is like a little Raspberry Pi hotspot that you can put up, and it'll give you a little app store so you can download Mesh Network offline apps, Google Docs collaboration suites. Kiwix is started from offline Wikipedia, but you can get static versions of almost anything you can think of on here to use offline. Project Nomad is kind of a more recent version that comes with an AI tool, and it does RAG to suck in all the databases like medical literature and things you might want to search over. So there's a bunch of things happening like that, but at the end of the day, it's still really important to communicate. So we worked on designing an open source satellite that anybody could launch for, maybe 100K or something like this. And you can see in the PCB design there that it's basically redundant parts because, things break in space. So we actually built the thing. And here's a fully completed design with solar panels. Gets loaded into a launcher, goes up on the rocket, goes into space, and then it flies over everywhere on Earth for 8 minutes twice a day and can forward SMS messages from your phone directly to somebody else's phone without going over the internet. Can also communicate over LoRa and other things like that. So I'm just going to flip through the rest of these real fast. Foresight is a group that has local AI nodes. I helped set up theirs in San Francisco, and they've got one here in Berlin at CIC, where you can go and get grants and funding and use of their local AI compute for projects. That's what the office looks like. I suggest you guys pop in and check it out while you're around if you haven't heard of it. Human Rights Foundation has a grant program supporting AI for individual rights, doing grants either to analyze authoritarian countries or to build open source privacy protecting AI tools. Another great thing to look into. There's some communities on Hilo. I'm just gonna skip over this, but there's a bunch of cool new GovTech things that are coming out with AI for coordination and communication. Like this one will take like everyone's input and kind of suck it out and divide it by category and help you analyze input from a group in a deeper way than a survey would. It's called Talk to the City. WeVote is doing a similar thing, kind of disintermediating legislation. So there's this whole platform of ideas that can live in an alternative ecosystem. And I'm gonna run out of time here, so skip straight to the end. If you guys got any questions. Do I? Oh, okay. Happy to go back over any of that, but I wanted to leave a little space for questions. If anybody's got any, no questions. It is primarily off-the-shelf components. We custom made some of it, but the rest of it's like Raspberry Pi type equipment. There is flight heritage for the same hardware, but it's not specially designed for space. That satellite is currently in space as of. He was asking how many satellites are in space. We have one satellite in space. A really important aspect is a test satellite, and to get regulatory filing for use of spectrum in space, you have to keep a satellite in the air. So while you're building your constellation, you put up a test satellite, and if it ever comes down or you lose communication, you have 2 years to get another one up, or you lose your spectrum filing, which is another important issue for a communication satellite. You have to have a filing that allows you to communicate on a country-by-country basis. So when you submit the filing, it gives you the ability for any country that didn't respond to your request to broadcast into their space, and then if they responded requesting coordination, you have to talk to whoever uses the same spectrum. So in our case, we have part of the LTE spectrum, 25 megahertz of L-band, so we can communicate on a channel that your phone probably already has. But it's also possible to communicate on open bands like Bluetooth Low Energy, or that your phone may support, or with another small device, not a phone, on LoRa. Okay, I think that's it for now. I gotta head to the airport, but if anyone wants to catch me in the next few minutes, I'll pass it over to ML.